To get some practice with triple angle formulas, I've brought two neat problems for us to solve today. So let's jump right in. Let's take a look at the first problem. Now, the thing that stands out in the first problem is that the terms on the left-hand side look a lot like the triple angle formula. This means we can just substitute our values in directly. If we do that, after a little bit of simplification and even a neat little trig formula that allows us to go from cosine to sine, we end up with an answer of tangent 9. Nice and easy. Next question is a little bit more complicated. We've got a little bit more involved. But if we're going to use the triple angle formula, we'll see that there are many different variations of it. There are many potential ones that we can choose. So the question is, which one should we choose? Now the answer usually depends on the problem you're given, but in this case we're going to go with the one at the end, this 2 cosine 2x minus 1. From here, we can multiply both sides by a negative half, get some stuff moving around. We finally get a positive half on the right hand side, which is nice. And from here, we're actually going to make a little clever substitution. Specifically this value of x over 2 plus pi over 2. So now, everywhere we see an x, we're going to just replace it with x over 2 plus pi over 2 to get to here. We can cancel out the 2's, which greatly simplifies things, and now we can use another trig formula, which will take us to a positive cosine x. Very nicely done. So we've done a lot of work on simplifying the right-hand side, but now let's look at the left-hand side, specifically this stuff in the brackets, because we can do a little bit more work with this. So we can actually expand all of these out. If we do that and remember some very important values that we should memorize by now, we can greatly simplify this expression to sine 3x over 2. So let's rinse and repeat. Similar logic follows for cosine x over 2 plus pi over 2. Just expand that out. Remember some very important values that we can use to simplify to negative sine x over 2. Now let's take the values that we found, plug them into our expression, take out that negative sign, and now we have an explicit formula for half plus cosine x, which is great because this form appears on every term in the left side of our equation. So let's move that off to the side. For example, let's take this third term here. This is equivalent to all of this. So what this means is we can rewrite all of our terms on the left-hand side in terms of ratios of signs, like this. And we can simplify this left side with some sweet cancellation, which brings us here, and we're so close to getting what we want, but we just have this annoying last term on the right side. But luckily, it's now time to use another trig identity, so you can see these are very important to know your trig identities. Since sine is periodic with period 2 pi, sine 81 pi over 40 is actually the same as sine pi over 40, which is great news for us because that means our whole expression is equal to 1 over 16. Very nice. Excellent. So, what did we learn today? Well, the first example showed a very direct application of the triple angle formula and was relatively simple. The second problem was a little less obvious, but the basic intuition for this problem is realizing we have 4 terms being multiplied and we need to somehow get an answer of 1 over 16, which is equal to 1 over 2 to the power of 4. And so it logically follows that a factor of half is probably coming from each factor in the left side of our equation. Now throughout the video, you may have noticed these why questions popping up. So these are meant to get your brain thinking about why we may be doing some not so obvious steps, just to help you develop that little bit of extra intuition. So now we're going to go over some of these. You'll remember the first one was picking the right formula. And we saw that the reason we chose this one is because when we multiply by negative half, this brings us closer to our goal of working towards half plus something, because that's what all our terms on the left-hand side look like, but we still have this annoying negative cosine 2x term. So to deal with that, we did this nice substitution x over 2 plus pi over 2. That greatly simplified things, get rid of the 2's, and then we could use this useful trig formula to switch between the signs to a positive cosine x. Very nice. This is exactly what we wanted, and the problem collapsed from there. So now that you've seen 2 problems using the triple angle formula, I hope you use them whenever you need to. It's worth knowing these since these tend to go hand in hand with telescoping series due to all the nice fraction cancellation, which you saw. I've already made a video on telescoping series with lots of good examples, some trig, some non-trig, so definitely check those out. And that's all for now.